Alright, so to check this, in order to properly diagnose this F7 code, we're going to first look at the 4903 relay. So if you look at the wiring diagram, right here is your 4903 relay right here in the middle. You're going to put your pins there, right at the 4903 relay when the unit is not on, but the unit is plugged in. And you're going to be checking for 120 volts. If you look at the wiring diagram, you're going to be going from L1 through the filter, through the fuse, to the primary interlock switch, over here to the 4903 relay. Your neutral is coming in, filter, cavity thermostat, waveguide thermostat, secondary interlock switch, through the inverter, which is just acting like a wire at this point, over to the 4903 relay. So if you put your pin there, you should get 120 volts. If you do not get 120 volts, well then you know that the problem is actually on your low side, and you got to check your switches, check your fuses. That make sense? All right. So you have your pins there, got 120 volts. Now you want to check it when it's on. So you want to put something in the machine, hit 30 seconds, whatever it is, hit start, check that relay again. You should lose your voltage. You should not have any volts there anymore. Once this relay closes, all the voltage will go over here to my inverter. So if the unit is running, you should not get any voltage there. That means it's working properly. Make sense? Okay. So that's what you're checking first. Next check, if everything there checks out okay, we're going to be checking for the 3.2 volts DC going to the relay control board. So this is that first little leg that the relay control board is going to be sending 3.2 volts DC over to the relay board to close that 4903 relay. So we're going to put our pin right there at P66.8, and we're going to check for 3.2 volts DC. If we don't get the 3.2 volts DC, that means that the relay control board did not send it to us, so chances are you got a bad relay control board. Okay? Next one you're going to want to check is right over here between the relay control board and the inverter. So everything checked out okay so far. Still have our F7 code. So now we're going to be checking to see if our relay control board and our inverter are talking correctly to each other. So we're going to check on pin number 3 on the relay control board. And we're going to be checking for that 5 volts DC with the oven off. And we're going to be checking for the 2.4 volts DC with the oven on. If you don't get that, depending on which one you get, you either got a bad relay control board or a bad inverter. So for instance, if you have the 5 volts DC there, but when it's running you don't have the 2.4 volts DC, that means your inverter is not sending that 2.4 volts DC back to your relay control board, and your inverter is bad. Make sense? Okay. Next one you're going to check is on pin number 1 of that same connector, and you're going to be checking for the power level setting, 3.1 to 1.3 volts DC. If you don't get that power level setting at all, or it's something kind of erratic, then you know that it's a bad relay control board. Sorry. Does that make sense?
Going backwards, that slide there, when you're talking about the 5 and the 2.4, which way are you reversing your source, your current source on that? Mm-hmm. You are.
Yep. So 5 volts is coming from the relay control board to the inverter, and then 2.4 volts when it's running is coming from the inverter to the relay control board. So if you just left your pin there, you should be getting 5 volts DC and negative 2.4. No, that's not right. You're going to be getting 2.4.
If you lifted that line, and you had a bad, let's see, the sourcing from the inverter board, the 2.4 back the other, if you look at that line on the 2.4, I should have the 2.4 still coming from the inverter board if my control board's loading it down, right? Because you're saying the other one's the source.
Yeah, my inverter is the source. So I should still, yeah, okay.
If I lifted the line.
If.
Do you get what I mean?
Yeah, I get what you mean. I'm just making sure. Yeah, if you just disconnected this and just checked there.
Well, just the one line.
Just this one line. What's a connector?
One line. Yeah.
It's a connector, but.
Yeah.
Yes, yeah, you should be getting that. Because the 5 volts DC isn't really.
Because then you've got a reverse current flow, you're saying.
Right.
You're going in the other direction.
Right.
They don't typically make things that way.
No, it is a little bit complicated.
It's usually a source coming from one direction.
Right. Okay, any other questions about the F7 code? Yeah,
Okay, you have this class, so to remember all this.
of course. I
Is
should write
this in the
notes.
tech sheet, you know, line item, check this, check this, check this, check this.
It's not in the tech sheet. It is, tech line does tell you though, check this, check this, check
But
this.
you gotta call the tech line to do it.
Correct. Or you can
Why
write
doesn't
notes.
Whirlpool put this out in,
It's in a update book, probably a year and a half ago,
okay?
that same information.
So check the
In
job.
tech bulletin? Okay.
Not a
That-
book, in one of the update books that I handed out.
Oh, okay.
CD, it's in there, we went over this.
Okay. It's on that CD, I got it.
Yes, one of the CDs, I don't know what, spring of 2010, I think it was,
Oh,
or
that one.
fall of
Okay.
2010.
If it's in there, then it is on service matters.
Yes.
It is on service matters.
Okay.
It is available. All right, going on to an F6 code. And this is the last thing we're going to talk about before we break here. F6 code for microwaves. That's usually an overheating issue. If you have what this picture is showing you guys, that's pitted metal, that's worn metal. You're not going to be able to repair that. Okay, but if you just have an arc mark inside there, there's a kit available that you can wipe off that arc mark, and you can paint the waveguide, replace the magnetron, and get the machine working correctly for the customer. So that is available for you guys. Does that make sense? Any other questions?
If it's pitted, you can't use the kit.
Correct. Here,